All right. Thank you very much, Wei. It's a pleasure to be here today. I've enjoyed getting to know all of you today. Very impressed with the Segal Design Institute. So the topic of my presentation today is on Empathic Experience Design, and you'll learn a little bit more about that. But looking at how extraordinary user experiences can affect your ability to do customer needs analysis as well as redesign. Before I start, let me just acknowledge the collaborators that I've worked on this project. So the first line here are people at the University of Texas at Austin that I've worked with. They're all graduate students, all the way from the undergraduate student way back in 2005 or 6 who said, hey, can we look at this problem? And I said, sure, and it ballooned into all of this. All the way up to the latest graduate student who's working on this, Paul Williams, who's actually a graduate of Northwestern and is now doing his master's at Texas. And then I'd also like to acknowledge a key collaborator, Katja Holte-Otto, who at the time we were doing most of this research was a professor at UMass Dartmouth and is now at the Singapore University of Technology and Design. And so she and I are very, very much co-conspirators and co-authors on all the papers that have come out of this work. All right, so I love this quote from Charles Vess, the president of the National Academy of Engineering. It was in one of Tom Friedman's articles in the New York Times a few years ago talking about innovation, the only mechanism that can really change things in substantive ways where creative thinking and practical know-how come together to do new things in new ways and old things in new ways. And I'm really preaching to the crowd here, I think, when I talk about innovation. You're all on board with respect to that. And so when I think about innovation, one of the things I think about is how do we really delight our customers, right? How do we get that really spark in their eyes when they see a new product and they say, oh, this is really cool, right? So the Kano diagram, I'm sure many of you have seen, right? You have your must-have customer needs, things that they just have to be there, and if they're not, customers are dissatisfied. You know, the simple level of safety, a basic level of safety, reliability. Then you have your baseline needs, which are often quite more straightforward to uncover in customer interviews. I would like a little more leg room, please, in my airline seat, and I would be willing to trade X number of dollars for that leg room. But then in the green there, you've got the delights, and those are a little bit more difficult to find, right? I'll give you a personal story of mine, which might show you how easy it really is to delight me with a product. But a few years ago, we bought a new SUV, and as I was driving down the road, a week or two after we bought it, it started to rain, and all of a sudden the windshield wipers came on. And I think literally there was a smile that came across my face, and I was like, this is really cool. I didn't know it had automatic rain-sensing windshield wipers, but this is really cool. So that's a small example of something that delights me, right? It might be something that's unexpected. It could be something that's provocative, but it's something that really pulls in that customer and says, this is a really innovative product. So we started our research study asking the question, well, how do you innovate? What are some of the characteristics of innovative products? And what should we do as a designer? Should we pile more functions onto the product? Should we change its size or make it smaller, or more compact, or more modular? Should we make it easier to use? What should we do? And we are engineers, so we really need to know what are the engineering level characteristics. And so it's important, of course, to think about things like market share and brand identity and all of these things as well. But as engineers, we need to know what are the engineering level characteristics of innovative products. So to investigate this question, one of the things we did is we went to several lists of award-winning products. And here's 3 of them that we went to. Time publishes their inventions of the year. Popular Science publishes their best of what's new every year. And then the Industrial Design Society also has their Excellence Awards every year. And so there were 3 of these lists that we went to from 2003 to 2008. So we analyzed 6 years of awards, and we looked among those lists for mechanically oriented products. So a mechanical product, an electromechanical product, something with some sort of mechanical emphasis, because we are mechanical engineers. So we took out just purely materials or purely service-oriented or purely software-oriented options. We were looking at sort of mechanically oriented products. So we found 197 of them that we analyzed. And what we tried to do was to try to find the engineering characteristics of innovation. So we combed through the award citations to try to understand what it was that these award committees saw in these products. And we thought, well, using products from these lists will be a little bit more a little less subjective than us just picking products off the shelf, right? Where we could stack the decks in favor of whatever conclusion we'd like to make. And so we investigated what characteristics were the most prevalent. So one of the things we did is we tried to come up with a list of characteristics. They're in the dark blue boxes here that we thought were fairly comprehensive. So among those 197 products, we could find characteristics that would in some way summarize why that product was cited as being innovative. And we were always thinking about that product relative to its competitors. So what does it have that they don't have, right? So we were looking at innovation in terms of a relative way. So if you look at some of the products, these were some of the products that were on the list that we looked at, right? So now some of these may have competitors out on the market that are even bigger and better and greater than they are. But at the time, these were on the award list. So you probably recognize a lot of them, right? Over here was the EXO laptop that came out of MIT's Media Labs. So one of the interesting aspects it had was under external interactions, it was able to be powered by hand crank as opposed to being able to use electricity. So it had interesting aspects with respect to energy flow. It had an early version of sort of the Kindle types of screens that were low power consumption, used a lot of RAM instead of hard drives, open source operating systems, all as an attempt to kind of reduce energy flow. It was a very rugged layout under architecture. You could also look at some of the other products here. This is one I actually have at home and use quite a bit. Have 2 little kids. That's a thermometer that was introduced by Vicks that you can tell a child's temperature just by rubbing it across their forehead, which is far superior, in my opinion, to some of the other places where you have to take children's temperatures, if any of you have little kids. The other interesting thing it has is it has a color-coded screen, so it'll blink green, red, or yellow, depending on whether the temperature is okay, it's borderline, or it's way too high. And the numbers are really large. So in the middle of the night, you don't even really have to read it or think about it. It just blinks at you and says red, that your child has a fever. So it has some really interesting user interaction characteristics. It makes it very easy cognitively to comprehend, even at 3 a.m. in the morning, it's really easy to see that it's either red or green. It makes it very easy physically to use it as well. You don't have to hold down the child with one arm and try to do some other operation to get your temperature. You can just slide it across their forehead and get that temperature. There are other interesting inventions here. This is the Nike Plus pedometer that got inserted into shoes. At the time that it was introduced, it was much smaller. So it had a much smaller architecture and could fit actually into the shoe or onto the shoe, which distinguished it from other pedometers. It also interfaced with your iPod. So it would interact with the infrastructure, which was something that was a unique characteristic, and it would broadcast your workout to your iPod or your iPhone, and you could hear it through your headphones, so you didn't actually have to look at it. So it had different sensory demands. You could listen as you were running to your workout. So a number of different characteristics. One of the things we were interested in is, do any of these characteristics appear more frequently than other ones? And so here's a summary of the 197 products that we looked at. We organized things by category. So you saw function. Does it add a new function? Architecture, does it change? Is the product different in terms of its size or its layout? Does it have different external interactions? So this is related to material and energy flow. A lot of sustainable products would fall into this category, or even modified information flow as well. So does it tell us more than other products would tell us? User interactions, does it make it easier to use in some way? So physically, does it require less dexterity, less strength? How about sensory demands? Do you not have to hear as acutely or be able to see quite as well, or have a perfectly lit environment in which to use it? Modified cognitive demands, is it significantly simpler maybe to use than other products on the market? And then finally there's cost. And not surprisingly, for an innovation list, cost isn't necessarily the one thing that really pops out at people for innovation, but we'll occasionally get a product there. So if you think about engineering design anyway, this probably isn't true for industrial design, but for engineering design, we have a lot of techniques that help us focus on function. In fact, we do functional modeling quite a lot. We have techniques that will help us look at architecture. So there's a lot of work that's been done in product architecture and product platforms. And we also, of course, focus a lot on how energy efficient and things like that our systems are. But what about this part, this user interaction? So 2/3 of our products were cited in terms of being innovative because they made it easier to use. And so as engineers, as mechanical engineers, maybe not as industrial designers, that's one thing that we don't necessarily think of as much when we do design. So that's where this idea of empathic design comes in. So this is a picture here of a guy who probably looks a little bit silly to you. But this was a senior design student actually at UT Austin, and his project was to design something that's called a litter. for transporting astronauts on the moon or Mars or wherever they happen to be. And so the idea is that if an astronaut becomes disabled or sick and cannot walk himself or herself back to the space station, someone needs to be able to carry them. And so their job was to try to design a litter, which is a device for carrying or transporting that astronaut by their astronaut buddies. And so one of the things they knew is that the context or the environment in which this would be carried out would be very, very different from what we have on Earth. So their astronaut buddies would all be wearing spacesuits, obviously. Those spacesuits are bulky, so they restrict your range of view. They restrict your motion, particularly of your neck, your elbows, your hands, your knees. And so one of the things they did was they designed basically a suit here, you can see out of a number of different contraptions, to try to restrict their motion, to try to challenge the modes of operating that product that would also be challenged if they were on the moon. And they got some really interesting results out of it. They were able to eliminate some of their concepts that involved things like kneeling on the ground for substantial periods of time, which they were unable to do in these particular suits. And so the idea of empathic design is to think about, okay, what might be some of the challenging ways of interacting with a product, these user-product interactions, and let's try to simulate those, either among designers or among customers, so that we can get better ideas for design and more ideas for redesign. So it's not necessarily a new idea. Let me tell you a little bit about where it comes from. So part of the roots are in lead user analysis. Many of you may be familiar with this. It's been advocated by Eric von Hippel from MIT. Lead users are people who push a product to its extremes, and as a result, they experience needs prior to the general population. And so they often find themselves innovating themselves. Here's a good example, I think, of lead user design. These are early mountain bikes from the 1970s and early 1980s. At that time, mountain bikes were not commercially available. When people first started taking bikes off-road in California, was a big zone for doing that. And so once they started taking street bikes off-road, they realized they had a lot of challenges. So when they ran their bikes through the mud, they couldn't use their brakes. So they had to invent drum brakes for their bicycles as opposed to the brakes that are typically on the rim. The frames weren't strong enough, so the frames were breaking and bending, and so they'd reinforce the frames. They'd put on aftermarket forks at the front to help reinforce them. More solid motorcycle-style brake levers so they wouldn't break when they took a spill. Quick-release seats that could be released as well in rough terrain. So lots of different things that they would try to innovate. The difficulty with lead users is that sometimes there aren't very many of them, or they may be difficult to find. Whereas common customers or designers are maybe much more prevalent. So common customers may be much more prevalent, and designers, we'd like to get them to build this type of intuition in what's needed as well. So you could have empathic design as well, where you conduct observations in the customer's own environment, often advocated as a way of doing customer needs analysis using ethnographic techniques, observing people, elderly people as they get into or out of their car, observing people at supermarkets. Again, the designer in this case, though, is doing observations. So we're wondering if we can't get the designer to actually experience some of them needs themselves. And this may be a fairly famous or widespread story of a woman, Patricia Moore, who spent several years as an elderly person in New York City. She was in her 20s at the time that this picture was taken, but she would dress herself up like this every morning. And she would bind her joints and do other things like that as well, so she could experience what it was like to be an elderly person. And so there are other examples of that as well. So on the left, you've got a photo from Ford Motor Company. Their suit that allows their designers to kind of experience what it might be like for someone maybe with limited mobility. I think they have a similar suit for expectant mothers that they can wear to see what it's like to interact with their products under those circumstances. They can fog your vision, they can impair your hearing, they can wrap your joints, do different things like that. And on the right is a similar suit from MIT's Age Lab, where they do similar things. The bungee cords here is to make it harder for you to climb stairs and do other things with your leg, and they'll wrap other joints, and you can see the neck wrapping and various things like that to try to impair motion. So these are not new types of things. Other people are doing this as well. One of the questions we want to do, though, is we want to try to formalize this process. So two things we're going to try to do is to try to formalize the process, articulate what's involved in it. And the second thing we want to do is actually empirically test it to see how well it works. Because a lot of the information we have on these types of techniques are very anecdotal. All right, so here's just a general flow chart, and it has two endings. You get to pick your ending. Actually, we're going to go to one ending, and then we're going to go to the other one. But you begin with a prototype product, something you want to redesign. You define your typical and your lead users, right? So who's your sort of standard customer, who's your lead user, someone who might push it to the extreme in one sense or another. You design empathic experiences so you can simulate those extreme conditions. And then you implement them. You can either take the brown route over here, the black route over here on the left, and you can have customers themselves that you interview, implement those experiences, and then perform customer interviews with them to see what kind of needs you get from them. Or you can actually have the designers themselves implement these experiences immediately prior to concept generation. You could do both of them if you like. So let's look at both of those paths. We'll start with the left-hand path first of all, and then we'll go to the right-hand path. So here's a number of different empathic conditions that you could implement. This is sort of a table of several of the many things that we've thought about. We haven't implemented all of them. But you could look at sensory types of impairments. So you could think about sight, hearing, touch, taste, smell. You might be trying to simulate what it would be like for someone who is sensory challenged to operate the product. But in many ways, that may also simulate what you actually experience under different conditions. So for example, it may be difficult for a person to use a typical cell phone if they're hearing impaired. It may also be difficult for you to use that cell phone if you're in a loud rock concert or if you're on the side of the road and the traffic's whizzing by and you can't hear very well. So we're not trying to design just for people who are disabled or physically challenged in some way. We're trying to make products that are better for everybody, right? So there are a lot of sensory challenges that you could introduce. You could use blindfolds for sight. You could use earplugs or ear protection headphones for hearing. There's a lot of physical challenges that you can simulate. So you can limit dexterity with things like oven mitts on your hands or wrapping particular joints. You could even simulate cognitive types of impairments. You could distract people by asking them to repeat particular pieces of information over and over while they try to program their VCR or whatever it is that we don't use VCRs anymore, their DVD player, and those sorts of things. So there's lots of different things we could look at. So far, what we've looked at are sensory and physical, and so I'll talk to you a little bit about those things today. All right, so let's start first of all with that path to the left there to customer needs analysis. All right, so the question up at the top is, can empathic experiences help customers become better innovators? All right, can we get better customer needs out of customers if we ask them to engage in these empathic experiences, right? These artificial disabilities, if you will. So here's an example product that we used. This was a study we did back a few years ago. This was actually stemmed out of an undergraduate thesis that we then expanded into a larger research study. But this is a simple two-person tent. Lots of people are familiar with it. That was actually part of the point of picking this. And so if we do typical customer needs analysis, we'll get a lot of direct needs out of the customers, things about size and shape and color and things like that. We knew that there was an innovative product. This was one of the products on our award list. This is called a Nemo tent that actually performs the same function in different ways. So instead of having poles and clamps on the poles and all those things that you have to fool with to get your tent up, this one's just inflatable. It takes less than a minute to inflate it, and so you don't have to deal with poles. You still have to stake it to the ground, but you don't have to deal with poles. But it wasn't offered anywhere in Texas. We hadn't really seen it anywhere. We were pretty sure that none of our customer base had seen a product like that. So we said, well, let's see if we can get them to innovate that and see how hard that would be to do. All right, so we went through our process. Let's talk a little bit about how we did it. We selected a product. It's a familiar product. That was part of the point. We didn't want people trying to figure out how to use something as they were going through the customer interview. A typical user would be a young, healthy weekend camper, and we had lots of those around on a college campus. A lead user might be could be someone who's disabled or challenged, physically challenged, but in this case, it could also be someone who's maybe assembling a tent late at dark or in the cold with heavy gloves on their hands. Maybe it's difficult to see. And so what we did was we designed empathic experiences to help simulate those. So we used oven mitts to simulate cold. We used a dark room to simulate a late evening or a late night assembly. And so we implemented those with customers. So under the control condition, customers were simply asked to assemble the tent and talk about it to us. And under the experimental condition, they were asked to assemble the tent with oven mitts on in a mostly dark room. So we made sure there was just enough light so it was safe. We didn't want anybody poking themselves with the poles. And our interview technique was free speech, so we just allowed them to talk. We would kind of probe a little bit as they were assembling it. And then at the end, we would do something we called categorical questioning, where we would go through different categories. Is there anything you'd like to say about the size of the tent, or the shape of the tent, or the weight of the tent? So we had a set of categories that we went through. We did not try to lead them on in any way. We only asked questions of clarification. So if they said, it would looks a little big, or it looks a little small to me, we'd say, well, what do you mean by that? Can you be any more specific? And that's how we would do the questioning. And then we analyzed the results for two things. One was breadth of feedback, so how many distinct comments did we get, and how many of these categories did we actually get comments from. The other thing we looked at was the number of suggestions for design changes. How many times or how many suggestions did each customer give us a really concrete suggestion for actually changing the tent, right? So it would be really neat, for example, if it opened by tensegrity, so I didn't have to assemble these darn poles, right? Or if the fasteners on the tent or the zippers on the tent, if you could change those in this way so I could better grip them with my oven mitts, right? That's a suggestion for a design change. Generally make it bigger or smaller, something like that wasn't really a design change. Okay. So the hypothesis was that typical customers who engage in empathic experiences, all right, will offer a larger number of redesign changes. So that was our hypothesis. They would realize more what the challenges were, how the product could be improved, than just a typical customer would. And so let's see if we're right. So here's the results, and you can see the standard error bars that are also on these results. So let's start over here. These are the number of categories of customer needs. So we had about 9 categories of customer needs, and this on average is how many categories the customers would hit. So this is our control group who just assembled the tent. Bright room, no oven mitts, nothing like that. Here's our experimental group who assembled the tent with the oven mitts on and in the dark room. So there wasn't a large difference in the number of categories. We got similar numbers of comments. The control groups tended to talk a lot more than the experimental groups. The experimental groups were just too darn busy trying to get the darn thing put together in the dark with their oven mitts on. So they didn't have a lot to say. So we got a lot more comments from them afterwards when we started doing a little bit of categorical questioning. So the blue part is the free speech as they're assembling it with very little probing from us. And the red part are the comments we got as we started questioning them. You didn't say anything about the size. How do you feel about that? You didn't tell me anything about how easy it was to assemble. Can you tell me anything about that? But the differences weren't that great in the end. Now let's go over here, and under latent needs, these are the number of redesign suggestions that we got. And so here's the control group, and you can see on average we had about 2 suggestions. And here's the experimental group. So these are the ones who did it in the dark room with the oven mitts on. And you can see on average we got about 5.5 suggestions. And so it's a very hugely statistically significant jump. And we did it with about 40 participants. 20 of them were engineers, 20 were non-engineers. It was about half male, half female. We didn't quite have enough data for me to break it down by engineer, non-engineer. But if you look at that data, what you'll find is that this technique, the control experimental difference, engineer, non-engineer, engineers get even more advantage from using this technique than the non-engineers. And we think it may be because they have a library of solutions or techniques in their minds that they might be able to draw upon, and this technique is kind of stimulating them to think about those things. All right, so many of the redesign suggestions we got were clearly tied to the nature of those empathic experiences we were asking them to do. So we did have people in the experimental, but not in the control group, tell us, boy, it would be nice if this thing would just inflate. Can't you make like inflatable poles or something like that? Or tensegrity types of things. So lots of times they would say that, can't you make this unfold like the sunshade that I have for my car? Glow-in-the-dark fabrics that were easier to see, ergonomic zipper handles, those sorts of things that were clearly tied to the types of experiences. And we weren't getting those types of comments typically from the customers in the typical interviews. All right, customer needs analysis. So that was an exercise using typical customers. These were literally students that we were pulling off the street in Austin and asking them to do our experiments. Now let's see what happens if we do this with designers. So can we have designers interact with the product that they're trying to redesign? Can we have them do it under these extraordinary circumstances, right? These empathic conditions. And why would we do that? Well, the hypothesis is that that would help focus designers on their interactions with the product, right? What are some of the challenging user-product interaction aspects of this product? Can we get the designers to really internalize, right, what those challenging interactions are, and then design for them, right? You could get a lead user to do this, you could get a customer to do this, and you could have the designer observe. But the idea here is that perhaps it's more beneficial for the designer himself or herself to do that, because then they'll really be able to internalize this need. Sort of in the same way, again, that they're doing it at MIT and at Ford. But we're trying to articulate what that process is and actually test it to see what kind of impact it gives us. All right, so we did two different design problems. One here on the left is sensory, and the other here is physical. So let me tell you the difference. Sorry, yeah. Okay.
So did you consider, instead of making comparison you did, control versus empathic, making comparison between different implementations of empathic, such as you think about someone who is doing this to Nicole, or observe someone doing Nicole?
We have thought about that. We have gathered a little bit of data on that, not enough to really do a study and talk about statistical significance, but we thought about that. That's an opportunity for future work for sure. Yeah, it's a great question. I think you'll get a little bit of the impact, but not as much. And but it'll be interesting to see just how much you get out of it. So it's a great question. All right, so we've got two problems we're going to look at here. One is sensory. So the problem here is to design a next generation alarm clock. Again, it's something that people are quite familiar with, but a lot of the alarm clocks they're familiar with tend to be pretty standard, right? They wake people up with noise in one way or another. And so the empathic experiences here are to include headphones, right, to make it a little harder to hear, to remind them that sometimes people don't respond to these auditory signals very well in the morning. Blindfolds to make it harder to see. It's dark, you don't have your glasses on. Oven mitts, you're not very dexterous when you wake up in the middle of the night to try to interact with these clocks. Here's a physical problem. So the problem here was to design a litter collection system for roadside litter collection types of activities. The prototype product in this case, it was just some simple alarm clocks that they were allowed to interact with. Here it's one of these handheld grabbers. Basically, you can pull the trigger here with your hand, and what it does is it grasps objects. But they were charged with designing a litter collection system. The empathic experience here, if you use one of these very much, it's actually very difficult to get the litter off of the end of it and get it into a bag. So in order to pick something up, if I have a bag in one hand and the litter collector on the other, I actually have to kind of do an operation like this to get it into the bag. And so there's a lot of different improvements that could be made to this system. And so one of the things we did was we wrapped the user's joints, we wrapped their elbow, and we also wrapped their wrist to help draw attention to the fact that if you use this very much, you get very fatigued. It's particularly in the shoulder, the elbow, and the wrist. So the process was we used an idea generation technique called 635, which you may or may not be familiar with. The 6 stands for 6 people. The 3 stands for 3 ideas. So each person will sketch out 3 ideas, usually on a different sheet of paper. And then they'll exchange it 5 times. So if there are 6 of us sitting around a table, I'll sketch out 3 ideas, so will everybody else. And then we'll give them to our neighbors, and it'll eventually come back to us. We usually use different color ink so that we can track who wrote what. And we'll often take an image of the initial design as well as the final design so we can see what the people sketched out first, and then we can see what it looked like in the end. And it may be very different from the beginning to the end. It's primarily sketching. There's no words. So you really do get, if you've got 6 people in a group, you've got 18 ideas or so to start with. And you can see what they've originally written down. You can also see it changing as it goes through the group. No talking as part of this exercise. So what we would have them do is interact with standard products. Either the control group would have no empathic conditions, the experimental group would. And then we would have them do this concept generation exercise. One of the advantages of doing this is that we can see, written down, we can see sketches of concepts. And so we can better assess what the person intended and whether or not it's feasible by looking at these sketches than we could if we had just keywords. The disadvantage over, say, looking at a design group over a design process is that we don't really get a chance to see designs evolve over time, get a chance to see what they're thinking over time and that sort of thing. But another advantage of this technique is we can run lots of people through it, and we have. So we have hundreds, we have about 600 concepts from UT Austin alone, testing different aspects of this empathic design. In terms of metrics, we looked at a measure of originality. So how unique and useful are these designs? So we would compare to existing products that were on the marketplace that we knew people had likely seen. So what are the best sellers at, say, Target and Amazon and Walmart? And whether it's unique relative to that, but also whether that solution is useful. You know, is it actually something that's going to wake someone up or help someone get out of bed or not, right? And then feasible. We also said, well, it could be very unique and useful, but it could involve, you know, planting sensors in someone's brain, which is probably not something that we're going to do anytime in the next 2 or 3 years, at least not on a widespread basis. And so we also looked at whether it's feasible. Is it possible? If so, is it technically difficult for this context? Would it take a lot of engineering to get it there? If not, is there actually an existing solution? Maybe not for an alarm clock, but for another product that we could kind of port that solution over, right? So it's possible to be unique, but also get a really high score on feasibility if the way you intend to achieve your alarm clock, for example, is already implemented maybe in something else and you can just port the technology over. We looked at also at the EED categories, the product categories I talked about at the beginning, to see not only if our designs would be more original, but if they would be targeted towards different aspects of innovation. So user interaction would be an obvious one, right? Because we're targeting that sort of category with our, empathic conditions. We had 2 raters for all concepts, for all the data I'm going to talk about here, and anytime they disagreed, they had to come to an agreement on what the rating would be for that. So you can imagine this is pretty time consuming. All right, so the hypothesis here is that designers who engage in empathic experiences right before they do concept generation are going to design concepts with a higher level of originality. Also that they should have a measurable impact on the types of innovation characteristics that are in their concepts. So let's see if that's true. All right, so let's look at what we've got here. We've got 2 problems, remember. Here's litter collectors, here's alarm clocks. This is all data that was taken at UT Austin. You can see the number of concepts we've got here. It's quite a lot, 126 for control, 100 for experimental, 173 over here for control, 172 for experimental. They're all senior level mechanical engineering students. Here you can see the originality score. A 0 means that that product already exists and it's widespread. A 10 means that it's highly unique. And you can see there were only a few sort of 10s in any of the data pools. The gray is the control, so no empathic conditions. The black is the experimental, so empathic conditions. And this is sort of a histogram of sorts. So if your technique is working, you would expect the histogram to shift towards the right? To have more highly original designs. When you look at the alarm clock study, you really see that. So if you look at the control group, 40%, despite the fact that the problem was to design a next generation alarm clock, right? 40% of the designs had basically no distinguishing features from alarm clocks that were widely available. Really, it was just, okay, let's put the button here or there, or very, very little that would distinguish it. And then you'd get, about a fifth, 20% from the experimental group would also be like that. Sometimes students had trouble coming up with 3 original designs, but they'd come up with 1 or 2. But then as you look at sort of the non-zero originality in each category, you see a higher level for the experimental group than for the control group. For the litter collectors, not so much. It's not quite as clear. You do have a little bit more here in terms of it's a little bit better here at the level 5 level and the 2.5 level, but not so much. So litter collector problem and the alarm clock problem are quite different. And I'll talk to you a little bit about that as we go along. So here's the alarm clock problem. So here's originality. Here's the average originality score for the experimental group. And the control group, you can see you've got about a 4, almost a 4, versus about a 2.5 or so. It's a statistically significant difference between the originality levels. In terms of feasibility, there's no statistically significant difference. They were all relatively feasible. There weren't a lot of really crazy designs out there. These students knew part of their incentive was that they would get extra credit in the class if they did good effort in these designs, so they had a pretty strong incentive to try to do well. They'd also seen 635 before, but not on this particular problem. All right, and so originality here is presented. We broke the concepts down into a number of features that they had, and we looked at all those features and rated each feature for originality, so how it woke someone up, what's its architecture, etc. And this is the highest originality score. Feasibility, same thing. We gave a feasibility rating to each feature, and whatever the lowest value was, that's what that concept got. If you look at the litter grabbers, the results were not as encouraging for the empathic technique. Here's originality. You can see the experimental, the average is a little bit higher, but there's no statistical significance to that. Feasibility, really no statistically significant difference there either. So one of the hypotheses we have about this is that with the litter grabbers, there are very few products out on the market, and almost anything they came up with was different from what was already there. So almost everything was getting a non-zero originality rating, whereas with the alarm clocks, there's a wide abundance of things that are kind of out in the marketplace. And so it was a lot harder in that case to kind of break that fixation on existing products. We can also see what kind of categories. So for example, here we've got the alarm clocks. What kind of categories of innovation do we see these things lying? And because we did these empathic experiences, we expected kind of a higher incidence of innovation categories in the user interactions, because that's what we were handicapping, right? And we did in fact see that in the alarm clocks. The other ones you can see there's a difference, but they weren't statistically significant. So the trend was that we were seeing a little bit more in the other categories as well, but those differences weren't statistically significant. For the litter grabbers, again, I said this was a little bit of a different problem because there weren't as many of these types of products on the market, so a lot of different concepts were innovative. You can see you've got a statistically significant increase here under user interactions. So it looks like our empathic conditions were serving their purpose, but you can also see a statistically significant decrease here in external interactions, thinking about material and energy and other things. So it seems like it might have taken some of the focus away from other categories and put them here, maybe for the experimental group. We're not quite sure. Some sample concepts. What did students come up with? Remember that these students had about 20 minutes to think about this problem and sketch things down, right? Actually, they had about 10 minutes to interact with the product. They had about 15 minutes to do their sketches. And then they automatically started rotating around. So kind of take that and keep that in mind, right? But here's a selection of some of my favorite designs from some of the things we looked at. So with the alarm clock, I'll show you several of those. Sometimes we had interesting ways of waking people up, you know, maybe spritzing water on their face or opening the blinds automatically or doing other things. In other cases, we had interesting ways of getting people not just to wake them up, but actually get them out of bed after the alarm went off. So this is a really interesting example of that. This is an alarm clock that's built into a toothbrush. So what you do is at night, you set the alarm to what you want it to do. It goes off in the morning to wake you up, and it has an accelerometer in it, so it senses when you're brushing your teeth, and it won't stop beeping until you start doing that. So that was kind of an interesting solution to getting you out of bed. Here's another solution. In this case, it started out as let's put headphones on someone's head and blare music into them, and it'll wake them up, and it won't wake anybody else up in the room. But that evolved into something that was probably a little bit more doable, which is let's do a little earbud that will fit down into the ear canal, and maybe we can use that to wake someone up. It does have some disadvantages. It could fall out of your ears and things like that, but if it's an earbud and it's down in the canal, it might operate a lot more like an earplug than anything else. Here's an interesting one to get you out of bed again, not necessarily to wake you up, but to actually get you out of bed. So this is a shaker flashlight. So the idea here is that it'll go off maybe with noise or flashing lights or other things to wake you up. But in order to turn it off, you actually have to shake it. And again, there are accelerometers built in, and you have to shake it hard enough, right, to actually turn it off. It also talks about, there were some interesting streams of ideas here about having sensors built into, some would have sensors built into rugs near the bed, or maybe even pressure sensors on the legs of the bed to sense when you got out of bed, and that was the only thing that would actually turn it off. And I thought that was those are some unique solutions as well. Here's an interesting litter grabber device. There were lots of different ones. I just picked out one here. This is an interesting device that's kind of simple. You've got your grabber here, but this one actually has one-way joints here, so you can grab your litter if you want, and then you can kind of sling it back over your head a little bit and put it into sort of a backpack here that also has wheels. So it gets supported by your back here as you're walking along. Most of the weight's going to be on your hips, but you can stand straight up and allow the wheels to take some of the load, or you can kind of lean forward a little bit if you're going up and down stairs or something like that to get a little bit of the load off of that. All right, so let's close and take questions. So some things we talked about today, some of the characteristics of mechanical products that are innovative. I talked to you a little bit about the results of the product study we did, looking at about 200 products. What type of things were prevalent there, particularly user interactions and external interactions. We talked about this empathic experience design method. We articulated kind of what it was, how you would do it. Showed how it was similar to things that are already being done anecdotally, and looked at some of the evidence that suggests where and when it might be effective, both for customers to try to do this as you're interviewing them, but also for designers to try to do that as part of their concept generation technique. So moving forward, gosh, there's lots of things we could do. Like lots of research studies, you answer a few questions and you raise a lot more. How well does it work generally? So we've just done senior level mechanical engineers. We've also, by the way, done freshmen, and I'll mention that in a second. What about professional engineers, or versus the novices? How well would it work there? How about different engineering fields? How about thinking about cognition or other types of things like that? We've only done sensory and physical. How does a customer's or a designer's familiarity with a product influence it? We're all doing redesign of products that people are pretty familiar with. What about new products or unfamiliar context? Can we use this to replace lead users? We haven't done that study. Can you gather enough lead users to get a critical mass and then compare their comments to what you would get from sort of an artificial lead user, like we've done in this study? Does it require physical simulations, as Professor Colgate was asking, or could we just do mental exercises, right? And say, well, what if I wasn't as mobile as I currently am? And again, how do they change with experience? So we've stumbled across some really interesting results. We did at UMass Dartmouth, partnering with Katja Holda Otto. Some of her data included things from freshmen. All the data I presented today was from UT Austin, but some of her data also included data from freshmen. And one of the things we stumbled across is that on the alarm clock problem, for example, we got much higher originality scores from the freshmen than we did from the seniors. And that, if you're an engineering educator, that may not be the result that you'd hope for. So one thing we can start thinking about is, can we measure innovation of our undergraduate students? Is that something we would want to do? Would it be useful? How would we do it? Is this a tool that we could use for that? We've repeated similar studies. I'm in the process of analyzing the data at UT Austin, which suggests the opposite effect at UT Austin. So our seniors score higher on these types of tests than our freshmen do. So it's a really, I think, an interesting thing to think about that we might be able to move forward on. All right, so I'll close with thanking my collaborators one more time, and I'll answer any questions that you have.